Okay, girls, so I'm going to do a quick recap of lesson 1, and that's pages 4 to 11. So at the moment, I'm in our class notebook under content library, and I'm looking at forces. So this was the lesson we had on Wednesday, the 15th of April. You are meant to basically just read through and just to remind yourself of what we did last time, and that's basically what I'm going to do right now. So I'm going to jump to lesson 1, pages 4 to 11. I'm going to minimize everything else on the left-hand side, and this is what we're looking at. So a couple of important things just to remind you of what we did last term. Obviously, first up, you must know what we mean by a force. And so that's the first major bit of information, and it's right there. The force is a push or a pull on an object. And then also the unit of a force is a Newton. We use this instrument to measure force. It's called a spring balance. And you'll notice on this spring balance, it actually has two scales. There's Newtons, and on this side, it's reading in grams. That's the important bit. Second page, you did this activity on what forces can do. So I'll skip through that, but the important 3 points about the effects of forces can be found on this page, and this is page 6. So a force can change the shape of an object. It's called deformation. Force can change the motion of an object. So if the object is stationary, instead of stationary, we also talk about the object being at rest. Force can cause it to speed up or slow down. Force can also change the direction of an object. And then how do we describe the motion of an object? There were a couple of words we used. So we spoke about velocity, and we also spoke about acceleration. So I want you to try and read through these paragraphs and really get a good sense of what we mean by that. And it's the kind of thing I'll come back to again. Going on to the next page, you did this activity about looking at these different diagrams and deciding whether it's a push or a pull and what effect that will have on the object. Okay, and that's what we work through. And then we get on to page number 8. We're talking about pairs of forces. Here was a lovely activity that we did, basically saying that forces do not act on their own, always in pairs. And we started looking at things like this and drawing diagrams like we have on the right-hand side. If I scroll across, you see we did a couple of these things. And this was quite important, actually. The idea of a free body diagram, that we take the object, we represent it as a dot. And so here was a question of James. He's got two girls pushing on him. We represent James as a dot. The forces acting on the object are then represented as pulling forces. So if we look at our free body diagram, which is this over here, you've got a force of 150 newtons to the left, 100 newtons to the right. And we can work out what we call the resultant force or the net force. So in this instance, 150 newtons to the left, 100 newtons to the right. What James is going to actually feel is a force of 50 newtons to the left. You subtract the two numbers. Okay, and that's resultant forces. So that was quite important to look at. And then that sort of thing, when we have two forces or forces acting in pairs, Isaac Newton was the gentleman who coined the phrases. He spoke about the one force being called the action and the other one being called the reaction. And you actually end up, if we just view this in a bit bigger, sorry, that's not jumped up completely out of the way, hasn't it? This is described by Sir Isaac Newton's third law of motion. And this is one of the definitions I asked you to look at. Okay, so that's looking on page 10. So when you push up against a wall, as you have in this instance, that's called the action. The wall pushes back on you, it's called the reaction. So for every action, there's an equal and opposite reaction. Okay, and that's this paragraph I was just referring to. Forces act in pairs on different objects. The force exerted by the second object is equal in strength, but opposite in direction. The red arrow is pointing to the right, the blue arrow is pointing to the left. And then just last term I asked you to read through this, and we're just going to finish this page 11 before moving on to the next lesson. Okay, so in the last activity we also saw that more than one force can act on an object at the same time. For example, when two of you are pushing or pulling on your friend in the middle, the effect of the different forces acting together depends on how big each force is and what direction each force is acting in. When two or more forces act on an object, the forces combine to make a net overall result. Remember, another word for net is resultant. So what happened when both of you pushed or pulled with an equal force? Okay, there's basically no movement of the object. And when forces are equal to each other and opposite in direction, they balance each other. This is important terminology we use in physics. We talk about balance forces, and we say that the net force is 0 newtons. What happened when one of you pushed or pulled harder than the other person? The object or the person that you're pushing on will move in the direction of the bigger force. Okay. So when the forces acting in the opposite direction are equal, we say that the net force are not equal, we say the net force is greater than 0. And that means that you have what we call a resultant force. Instead of resultant, we also talk about a net force. Sorry, I need to highlight with a pen. If the forces are equal and acting in the same direction, there will also be a resultant force. Okay, so you can think of tug of war and two groups pulling, and if the one side is exerting a bigger force than the other side, we have what we call a net force or a resultant force. The forces are what we call unbalanced. Okay, and you have basically the object being pulled. Okay, so that's where I'm going to stop, and that's the end of basically lesson 1. So you need to go back and find all of the words that you need to put into the definitions page. It's actually in this lesson itself. Thank you.